Modern refrigeration. Chapter 6, Basic Refrigeration Systems. Some of you watching this PowerPoint video are saying to themselves, I'm not supposed to be studying Chapter 6. Well, either if it's before the time you're supposed to study, or if you've already studied this chapter, this is absolutely the most important chapter in the book. This teaches you everything. Nothing else works in this book without this chapter. So you're probably going to cover it a few more times before you leave your training here at Southern Technical College. But here's Chapter 6. The objectives that you'll go through in this PowerPoint presentation. The number one is the heat transfer. Heat transfer is everything. Without heat transfer, no one's cool, no one's warm. The second thing is more about pressure changes and phase changes. And of course, we're going to go through the four components of the refrigeration cycle. We're also going to look at what happens with the compressor and the TXV, which is shown on the screen, and understand their purposes and how they work. The purpose of refrigeration. The number one thing it does, and we've talked about this in class, is it removes heat from the conditioned space that you live in. And to do this, this PowerPoint uses the sponge theory that the refrigerant, when it goes through the evap coil, is like a sponge, and it soaks up all the heat that goes through the coil. And then it transfers that heat into the refrigerant that goes out to the outside, and that sponge is squeezed out there and gets all the heat out of it. It's kind of simplistic, but I think you all have a grasp on that at this time. This is your standard refrigeration cycle that we've seen many times on the board. The major things, the refrigerant, it absorbs the heat inside and it releases it outside. It also changes a liquid to a vapor and a vapor to a liquid. Without the compressor, nothing happens. If you look at this compressor in this picture, it's taking the light blue, low pressure vapor and turning it into the light red or pink high pressure vapor. The discharge line takes it from the compressor to the condensing coil. It goes in the condensing coil as a vapor, high pressure, high temperature, runs through the coil, and with the help of an outdoor fan, it changes it into a high pressure, high temperature liquid. The liquid line takes the refrigerant from the condensing coil to the metering device. The metering device steps down the pressure to about 1/3, and it meters just a little bit of refrigerant into the evap coil. When it goes in the evap coil, it's about 80% liquid, about 20% flash gas or vapor. As it works its way through the coil, there's a fan that assists it, that changes it from the liquid to a vapor. And as it changes, it uses the heat in the home to make that change happen and takes the heat off the air that's passing through the coil. And then it goes through the suction line back to the compressor. High side, low side. High side pressure equals high temperatures for heat rejection. Low pressure equals low temperature for heat absorption. The low side heat is absorbed into the system. The high side heat is rejected from the system. The compressor divides low side from the high side, and the metering device divides high side from the low side. These have been on test questions in the past for you, and they might be there again in your final. Compressors are motor-driven items. They don't move, they don't do their job without a motor built inside of the normal residential unit. They're hermetic devices, so the motor is sealed inside the unit. The compressor squeezes vapor into small volume. High temperature, high pressure is what it turns the low pressure, low temperature into. Separates low side from the high side, creates high pressure on the high side, it creates low pressure on the low side. You're probably saying, how can it create high pressure and create low pressure? Because the low pressure is only low because the compressor is sucking the suction line and pulling that refrigerant out of it. If it stopped doing it, the low side would become high. So it facilitates the movement of refrigerant from the low side to the high side. Most expensive and crucial part of this system. A lot of these parts, they cannot work very well and you'll still have cooling. The compressor doesn't work, it just doesn't work. The system needs this item. It is the heart of the system. Evaporator and compressor. The evaporator is a low pressure liquid. Refrigerant soaks up the heat. The liquid becomes low pressure vapor. It boils off inside the evap coil. If we're talking about 410A, it boils off at about 53 degrees. So as long as the air coming through the evap coil is over 53 degrees, it's going to work fine. The compressor draws in low pressure vapor and the compression results in a high pressure vapor. The condenser and metering device. The condenser, the temperature difference causes the release of the heat. As the fan blows across it, it takes that heat and disperses it out of the unit. The high pressure vapor becomes high pressure liquid. The TXV that's going to be on the other end of this condensing coil needs to have a liquid to work. It cannot meter vapor. It has to be in a liquid state. So no matter what you think the condenser does, the most important things that it does is changes the vapor to a liquid. The metering device restricts flow of the liquid refrigerant. Not all the way, but just enough to make the system work. High pressure liquid becomes low pressure liquid. Reciprocating compressor. This is the old style compressor, not used a lot anymore, but it's used in small appliances usually. Ice machines, refrigerators, those kind of things. Most AC and heat pump systems use a scroll compressor. It's the #1 unit sold out there right now. But this is how a reciprocating compressor works. It provides both suction and compression, operates using a back and forth motion, kind of like a piston in your automobile. Oil separation. The purpose of oil: lubricates compressors and mechanical parts, and lubricates motor and bearings. Oil separators contain baffles and screens to collect oil. Prevents excess oil from interfering with operation, placed between compressor, exhaust, and condenser. Here's an oil separator. It's not something you see often, but this is what one looks like. Condenser. Compressors discharge high pressure, high temperature vapor through the discharge tube. The vapor travels through the discharge line to the condenser. Condenser changes all vapor into liquid, removing latent heat. The condenser subcools the liquid, removing some sensible heat. Liquid travels through liquid lines to the metering device. And the subcool on this is very important. It's the only way to charge a unit that has a TXV. And we went through this in class and we've had questions on it. But remember, it's just the gauge temperature before or after the condensing coil and the actual temperature on the liquid line after the condensing coil. Here's two types of condensers, air-cooled condensers and water-cooled condensers. In Florida, there are quite a few water-cooled condensers, but they're still considered rare. Liquid receivers, storage tanks for liquid refrigerant. It allows charge to be less critical, holds most of the refrigerant charge for system servicing, and they have a little footnote there, not used on capillary tube systems. Liquid line carries a liquid refrigerant to the metering device, and that's coming from the condensing coil, often made of copper. And honestly, I've never seen one that wasn't made of copper. I'm sure there's some commercial units that don't use that, but I have always seen copper lines. It's connected by brazing or flared fittings. Usually you see flared fittings in mini splits. Those units seem to be more friendly to connect without the brazing. Smaller diameter than the suction line. Usually the liquid line is either 3/8. In old systems, they used to be 1/4 inch, 5/16, but now they're pretty much 3/8 and maybe 1/2 inch. May be in contact with the suction line. There are systems that use the liquid refrigerant to assist in the running of larger pieces of equipment. Liquid line filter dryer keeps debris from entering the metering device, remove moisture from the refrigerant. Moisture might otherwise freeze and cause obstructions in the coils. Moisture can form sludge and acid. Metering device controls the flow of refrigerant into the evaporator, reduces liquid refrigerant from high pressure to a low pressure. And that's been some of the questions that we've had on our test. What reduces the liquid line pressure? It's always the metering device. Located between the liquid line and the evaporator. Other names are refrigerant control, refrigerant flow control. Several different types of metering devices exist. Most of our units have a fixed metering device or a piston in it. There's capillary tubes and the TXV. The more modern units will have TXVs because they're more efficient. They are a little bit more complicated to deal with. And when you have a TXV, you cannot use superheat to charge a unit. You can only use subcool. Type of metering devices. Here we go. Fixed orifice, capillary tubes, TXVs or thermal expansion valves, AXV or automatic expansion valves, EEV or electronic expansion valves, low side flow and high side flow. Some of these are really used in commercial units and chillers. Usually the top three are the only ones you'll see on residential systems. They show the TXV on the right-hand side there. The sensing bulb is the key to this. The sensing bulb is what tells the system to let more refrigerant in or let less in. Process of evaporation. Warm air passes between the evaporator fins. Heat is absorbed by the liquid refrigerant. And we've talked about this in the past. It's not you're putting cold air through the unit. You're actually, the air that went in was warm, and the heat is actually affixing itself to the coil and getting into that refrigerant. In nature, things that are warm want to be attracted to things that are cold. So the heat on the air is jumping off the air and jumping onto the coil. Liquid boils into a vapor. Again, this is a place where it's 410A. It boils about 53 degrees. The temperature of air flowing over the evaporator becomes increasingly colder. Cold air cools and conditions the area. Here's a picture of an evaporator. This is pretty good size. This is not one you'll see in a residential home. This is a commercial evaporator. But you can see the little fins on the side, the little tubes on the side. Those are capillaries. That's what delivers the refrigerant. Accumulators. These are found on heat pump systems. They capture liquid refrigerant in the suction line. Liquid can damage the compressor. Accumulators hold liquid refrigerant, not required in most small systems. Usually they're in heat pumps. It's just something that it needs to work properly. You'll find these units are not copper. The ends that you solder onto are. These are usually just metal. And they do rust if they're not kept off the bottom of the unit and if they're not kept painted. Suction line carries the refrigerant vapor from the evaporator to the compressor, carries superheated vapor with minimal flow and resistance, should slope from the evaporator down to the compressor. So you're returning that oil that might be in the coil back to the compressor to work as the lubricant. Made of copper tubing. Tubing should be insulated to prevent condensation and absorption of heat in the unconditioned space. Refrigerant is superheated above the saturating point. Superheated but feels cool. Last but not least, a filtered line dryer. It's located between the suction line and the compressor. It's designed for low pressure use. It protects the system from acid and contaminants, often used temporarily. Most manufacturers say you're not supposed to leave these on, and the reason why, they plug up easily. This one has the test ports on both ends, so you can put your gauges on there, and if you're losing more than a couple pounds of pressure from one side to the other, it's plugged up and you need to get rid of it. It might not be all the way plugged up, but it can cause you problems. So you remove it. Of course, you evacuate the system, remove it, solder on a piece of pipe, pull a vacuum on the system, recharge it with the same refrigerant, and you should be fine. Well, this is the end of this PowerPoint. I hope you enjoyed it. There's other PowerPoints out there online, other videos for this kind of stuff. You really need to know, like the back of your hand, the refrigeration cycle. Have a good day.